Hello everyone. Our team's topic is Yelp picture recommendation. First, I will introduce our motivation and the dataset. Our motivation is to make Yelp users happier by showing them more beautiful photos. There are several features in appealing photos, such as depth of field, contrast, and alignment. Part of dataset is from Yelp Challenge dataset. It contains more than 200,000 pictures. We also download some beautiful pictures from this photographic website and use Google search to download some ugly photos. Photos in dataset can be roughly divided into 5 categories, such as food, drink, inside, outside, and menu. To avoid recommending only one kind of photos, we also do classification.
Okay, here comes our algorithms and methods. So generally, we want to build this pipeline. We first input a batch of Yelp photos, and we into these two scoring system and diversification system. These are both deep neural nets built for picture recognition. And we output ranked photos based on both on scores and the category they belong to. For our scoring, we use a AlexNet. It is a deep neural net with 5 convolution layers, and the input is 227 by RGB pictures. So these are neural networks that we can choose from. Generally, the higher the y-axis, the more accurate the models are, and the higher the x-axis, the longer time it took to train. So for our scoring, a AlexNet, which is very efficient, is enough. And for our classification, we decided that we need more accuracy. So we use this pre-trained inception models with higher accuracy. These two models are both relatively efficient compared to other models such as VGG. And so here's a brief summary of our results. So we first try SVM on Spark to do the scoring, and the precision is less than 70%. Then we built our 2-layer basic convolutional network and reached a precision of 85%. Then we built a AlexNet and increased our size of our data set. Then it's reached a precision of 89% for scoring. And for classification, a 2-layer convolution models will only have less than 80% precision. So we retrain the final layer of inception models and reach the precision of 90% of these 5 categories.
So here is our result. We picked several restaurants on the Yelp official website. As we can see, the original cover photos are somehow ordinary and a little bit dim. After running our algorithm, we can replace these pictures with more beautiful pictures. Here is another example. Hamad Palace is a restaurant with 4.5 stars on the Yelp website. However, it is really weird that it just used 3 menus as a cover photos. After running our algorithm, we can replace these photos with beautiful food and inside picture of the restaurant. It will be much compelling to the customers. Here is another example. Upstate is a seafood restaurant. After running our algorithm, we can find better photo of oysters. Also, we have met several challenges. First, it is hard to modify the model, adapt to constantly updated data streams, and changing trends. Second, the quality of photos is a relative subjective factor. To find a ranking system to fit everyone's favor, it is really hard. For the future plan, we will build a nice UI interface to let all users test the quality of their own pictures.
To have a brief demonstration of our methods. First, we do scoring system. We first process the data, do some cropping, resizing, and then we feed them into our AlexNet. And you can see that it's already start training and the first letters. And then it's for our classifications task. We retrain inception model. These are some hyperparameters. We use flip, left and right flip, and random cropping of 80% to further enlarge our data set. That the training is finished. So first check out our scoring system. After several retraining, we reached the precision on validation set of more than 90%. And here is the scores of our sample input. We can check that there are good pictures has higher scores and there are bad pictures have pretty low scores. Also, you can check our classification system. After 5,000 iterations, it's also finished, and the test accuracy will be 88%, while the train accuracy is more than 95%. We can take a look at the tensor board. We can check the accuracy and the loss of cross entropy, and take a look at the graph. The model we use is Inception version 3. It's a very deep neural network, has more than 10 layers of hidden layers, and very accurate at the classification task. Then we will finally demonstrate our results based on the scores of the actual picture showing. Thank you.
We pick out 50 photos in different categories. These photos are sorted by scores we get from the recommendation algorithm, which means beautiful photos will rank in the front.